Number 19, the function f is continuous and differentiable for -2 is less than or equal to x is less than or equal to 1. If f of -2 equals -5 and f of 1 equals 4, which of the following statements could be false? I'll be honest, I'm struggling with this one because I don't agree with the answer that's on the answer key. But I'm not confident in that, so I just want to be straightforward with you. But I will explain at least my thought process on this one. So part A says there exists C where -2 or on the interval such that f of C equals 0. I understand that this is true, must be true, because at an x value of -2, we've got a y value of -5. Let's say somewhere down here. At an x value of 1, we have a y value of 4, somewhere up here. So if the function is continuous, which it says that it is, that means to get from this point to this point, you've got to cross the x-axis somehow. So there will be a value where the y value is 0. Okay, part B, there exists C on the interval such that f prime of C equals 0. That is the conclusion of the Rolle's theorem. It must be true. Because the function is continuous and differentiable, Rolle's theorem says that there will be some point in that interval where the derivative equals 0. Part C, there exists C on the interval such that f of C equals 3. Again, to get from this y value of -5 to a y value of 4, you're going to have to come across the y value of 3 somehow. Because the function is continuous, you won't be able to get from here to here without having a function value of 3. Part D, there exists C on the interval such that f prime of C equals 3. 3 is the slope between these 2 points, the endpoints of your interval. The mean value theorem says that if marker's not working. If f of A, which in this case is -2, equals f of B, which in this case is 1, then there will be a point where the derivative of that point equals the slope between those 2 points, which in this case is 3. But if we look at what we were given, f of -2 is -5 and f of 1 is 4. So the requirement in the mean value theorem that says those 2 y values must be equal in order for this to be true, in this case, it is not true. So in my opinion, part D could be false. It's not saying that it is false, but we definitely can't say that it's true because our function does not meet the requirements of the mean value theorem. So we can't use the mean value theorem to say that that is true. So it could be false. Sorry, I'm just realizing now that I do agree with the answer on the answer sheet. I don't know how I did that. I've been thinking this whole time that I did not have this one correct, but I absolutely do. I just explained it perfectly. So perfectly that I surprised myself. So hopefully that made sense to you. Honestly, I've not even looked at part E because I was so caught off guard by part D, and I shouldn't have even been. So let's look at part E. There exists C in the interval such that f of C is greater than or equal to f of x for all x on the closed interval. I'm not quite sure exactly what that's trying to say, but I think I've already done better than I even really thought I would. You have your answer. Part D could be false. We definitely say that it. Sorry, I'm still trying to figure out part E. If I figure it out, I'll email you guys another video later. But as of right now, we know for sure part D could be false. We definitely can't say that it is true. It could still be true, but it also could be false. The rest of them so far must be true. Parts A, B, and C must be true. Part D could be false. And then I'm really not sure about part E yet. I will get back to you if I can figure it out.